Welcome. Today we will explore the beautiful mechanics of the Fourier series. In mathematics, the Fourier series allows us to decompose complex periodic functions into a sum of simple, oscillating functions, namely sines and cosines. We will attempt to construct a square wave, which is a signal that instantly jumps between two levels. To do this, we start with a single rotating vector. This vector rotates at a fundamental frequency, and its vertical height traces out a pure sine wave. Watch as the yellow dot traces the path. This is our building block. It is time to refine the shape further. We add the fifth harmonic. This vector is 1/5 the size of the fundamental, and rotates 5 times as fast as this smaller circle spins at high speed. It adds small ripples to the wave. These ripples are crucial. They work to flatten the top of the wave even more and steepen the sides. The transition from high to low is becoming sharper. The mathematics is strictly following the formula, summing odd harmonics with amplitudes inversely proportional to their frequency. We continue the pattern by adding the seventh harmonic. 1/7 the radius, 7 times the speed. At this stage, the combined motion of the circles is becoming quite intricate. The tip of the vector chain is now tracing a path that hugs the outline of a square much more tightly. The Gibbs phenomenon becomes visible. Those little overshoot spikes at the corners of the square wave. These are mathematically unavoidable in a finite series, but they get squeezed tighter as we add more terms. Finally, we add the ninth harmonic. With just these first 5 terms, the first, third, fifth, seventh, and ninth, we have achieved a recognizable square wave approximation. If we were to continue this process to infinity, adding smaller and faster circles forever, this shape would become a perfect square wave. This elegant dance of circles demonstrates the power of the Fourier series. That even a jagged, discontinuous signal like a square wave is simply a choir of smooth, rotating circles singing in harmony. Thank you for watching.